How's it going, everyone? This is Mr. Scheidegger. And as you are hearing this, most of you, I'd be in Orlando, Florida. And I guess a couple of you guys will be on your way to Detroit. But anyway, I want to go over. Okay, first, I apologize for number 3. I should have worked it out in advance. I can do the fun one for you. But you may or may not be. I can just see Laura shaking her head. But anyway, the answer I got was at least 17. So if anyone got that or would like to argue with me about what they had answer, we can do that later. But the challenge there was to try to get the expression all in terms of dimes and be able to solve an inequality. I'm a little apprehensive about showing it, but I could maybe show it I could show it at the end just for those people that are curious. And but I apologize. I think it was a little bit above us and not something I prepared you well for, and so I apologize now. But we have what I have for you today is somewhat light. I think it's not too much. I have one more type of problem that I'd like to show you, and then if you look on my essay, you're going to see an assignment with 6 problems to do. 4 of them are problems that are related to the ones that you did last night and the ones we did the other day in class. And the next ones are, if you can take your packet out, are going to be related to questions that have to do with we're going to talk about. I'm going to just, like, in general, just say objects moving in water or air currents. Okay, so what does that mean? Basically, I'm talking about, and I don't like that pen size. I guess what I'm talking about is if you're in a canoe and you're going with the river, you end up going you end up traveling faster relative to the shore. If you are in a canoe and you're traveling upstream against the current, you tend to go slower compared to people at the shore. And so, and then similarly, if you're in an airplane and the wind is moving in the same direction as the airplane, you end up increasing your speed. They call that a tailwind. And if you're going against the wind in an airplane, you get what's called a headwind. It slows you down. So I'm gonna what I'd like to do is kind of scaffold a little bit and try to give you some ideas on some of the thoughts that we're gonna need to be able to execute these problems. So first of all, I want to start with a formula, and I'll pretend like we all did well in Mr. Dreyfus's physics class. But one of the formulas that we have is that the speed of an object times the time is equal to the distance something goes. Okay, sorry about that sound. That siren was my phone going off. That was my wife calling me, so apologize for that. But anyway, yes, velocity times time equals distance. I mean, think about this. I went up to Orlando, and I was traveling all of, actually this is not true, but pretend I was traveling 50 miles an hour. If I was traveling 50 miles an hour for, say, 4 hours, how far is that? 50 miles an hour for 4 hours. Wouldn't that be 200 miles? Yeah. Well, anyway, that's correct. And so I just want to demonstrate that the formula actually does work, right? Velocity times time equals distance. So that's going to be something we need to hold on to. And let's go ahead and erase my little example here. I'm so confused about this eraser. There we go. All right, so, and why does that happen? Okay, anyway. Okay, so let me get rid of that for now. All right. Now, so we're going to be using this for a lot. We're going to be using this, and you may remember in the old days that that sometimes what we can do is when we're dealing with velocity, time, and distance is we can use a chart. And that's going to happen. We're going to be, I'm going to ask you to, if you look at the problem on example number 6 on your, this is on page 2 in the packet, you're going to see a little grid. And in a moment, what we're going to do is we're going to use this grid to organize the information of the problem. For the most part, what we're going to do is put a velocity here. We're going to put time here. Distance is going to be here, and in the problems that we're going to be doing, we're going to be going to something, and then we're going to return. And so, in general, this is what we're going to be looking at. And boy, that looks like a real big mess to me. But what I'll do in a moment is I'll take a picture of it. Actually, let's go ahead and go to the second page, and let's go ahead and do example number 6 together. So, okay, so here is here's the problem number 6, and again, as I told you before, is we're going to be calling, we'll be calling this the first. Ooh, why does that happen? Okay, so this is going to be the velocity, and this will be the time, and this will be the distance. And let's go ahead and let's read the question here first. It says, with a tailwind, a plane traveled 480 miles in 3 hours. With the same wind as a headwind, that means it's slowing it down, the return trip took 30 minutes longer. Find the plane's airspeed and the wind speed. So, before we go too far into this problem, what I want you to think about is that we have two things working, two things going on. Take a look at my little diagram here. Say we have our little airplane, and the airplane is traveling. Let me get the little propeller there. The airplane is traveling in this direction at, say, 500 miles an hour. But say the wind is pushing it at 100 miles an hour. That's one heck of a wind. Well, the combination of the wind, of the plane speed in the air and the wind pushing it means that it's going to be going 600 miles per hour relative to the ground. I know, relative to the ground makes everyone think physics, and it like freaks them out. It just means that for the people that are looking at the airplane below, it looks like it's going 600 miles an hour because the wind is pushing it. What happens when the plane's going in the opposite direction? When the plane's going, and that's called a tailwind, by the way. We're going to call that a tailwind because it's pushing the back of pushing the back of the airplane. So tailwind. So if the plane is going in the opposite direction, so let's say it's turning around, and now the airplane is going in this direction at 500 miles an hour. But the wind is pushing it this way at 100 miles an hour still. So the wind didn't change. It's just the plane changed direction. Well, what does that mean? If the airplane is in the wind and the wind is going 100 miles an hour to the left, but the plane's going 500 miles an hour to the right, that means that if you're on the ground, it looks like the plane's going slower. It's going 400 miles per hour. Same thing happens if you're in a canoe. You know, if you're in a canoe and you're going 5 miles an hour in the canoe, so here's my little canoe here. Oop, that's not a very good looking canoe. But say you're in the canoe and you're traveling at 5 miles an hour in one direction. Oh God, I can't stand all that stuff. Say you're going 5 miles an hour. You're rowing it at 5 miles per hour, but the but the water's going backward. It's you're in a river and you're going against the current. The current's going 3 miles per hour. Then it looks like you're just going 5 miles per hour. You're going slow because you're going against the current. But say you're going with the current, down the rapids. Then what happens is the current is going to be working in your favor. So say I turn the canoe around. Now the water's going at 3 miles per hour and the boat's going at 5 miles per hour. But in this case, what happens is they add together. You're going 8 miles an hour. The person that's on the shore looking at you sees you going much faster. You're going 8 miles an hour if you're going if you're going with the current of the river, but you're going a lot slower against it. It's probably not really good examples. I mean, I'm from New England where we actually have rivers. You guys have a thing called the intercoastal, so it may not be something that many of you have experienced, but I'm hopeful that you can understand how that works. If this makes some sense. But anyway, let's go ahead and let me show you how we're going to express the velocity. Well, first of all, we're going to call the airspeed. Let's call the airspeed A. And actually, the airspeed. Let me just define that before we're done. The airspeed is how fast the plane speedometer says. So I don't know if a plane really has a speedometer. Some of you guys may know, but if the plane did have a speedometer, this is the airplane's speedometer speed. The wind speed is just that. It's the speed of the wind, and we're going to call that W. And I guess what we can call the airplane speed is A. And if we use these two variables and we have what's called a tailwind. Now a tailwind is what pushes the plane. That's when the airplane is going in the same direction as the wind. If that's the case, what happens is the total speed is the airplane speed plus the speed of the wind. Is anyone shaking their heads? Okay. Regan, are you paying attention? Anyway, you got this, right? Who else? I'm looking around. Okay, well, anyway, you put the two speeds together, and if you need to stop for a moment and have someone explain, that would be great. What would be the speed with the headwind? Headwind means it's pushing against you. So think of your, the hurricane's hitting and you're trying to run into the wind. What happens? It slows you down. So that happens, we get the airspeed, the airspeed or the speed you're running, and then you're going to subtract from that the wind speed. So what does that look like? That means that these are going to be my velocities. And so I'm going to go ahead and put these into my little chart. So don't panic yet. So let's once we've done a couple of these, you'll start to get the hang of this. So the first thing that's happening, the first part of the trip, is a plane is traveling 800 miles in 3 hours with a speed as a headwind. So in this case, we're going to be going. I'm just going to say we're going to go the trip. We're going to go to whatever, and then return. It's a round trip. So going to the destination, we have a headwind, and the headwind slows it down. That's A minus W. The time it takes to go there, can anyone see it? It's right up here. It says 3 hours for the first trip. So the trip, the first leg of the trip, it's with a headwind, so it's A minus W. The trip is 3 hours long, and the distance that we go is 840. When we return, we're going to be going with the wind. Oh my God. As a headwind, the return trip. Oh my goodness. Oh, you guys gonna kill me when I do this? It says the headwind is the return trip, so the A minus W needs to go on the bottom. If you could just make this a plus, because clearly what that means is the wind that the wind speed was going with the airplane on the first leg of the trip, and then it's going the opposite direction on the return. So, and it says 30 minutes longer. How much is 30 minutes in hours? And 30 minutes is half an hour. So what that says is with the wind going against it, took half an hour longer. So instead of 30 minutes, I'm going to write this as 3.5. That's the same as 3 hours and 30 more minutes. Again, the distance is still 840. All right, so now that looks like a big mess, but it's not. What we have to do is this creates our two equations. And now that we have our two equations, we can solve either using elimination or substitution. What are the two equations? I have A plus W times 3. I'll put the 3 in the front, just because that's how you guys are used to looking at it, equals 840. And I also have 3.5 times A minus W. This is the bottom equation, equaling the same distance. It might be worth trying to reduce reduce the equations first. Okay, so believe it or not, this actually simplifies pretty quickly. If I divide the first equation, both the left and the right, if I divide it by 3, I get A plus W. If you divide the 840, if I divide it by 3, 3's cancel here, and the 3 goes into the 8 2 times, carry the 2, 3 goes into 24, 8 times, and a 0. So A plus W equals 280. And believe it or not, you can actually divide the 3.5. We divide this by 3.5. 3.5's cancel, and believe it or not, 3.5 evenly goes into 840. It goes into it 240 times. So now we get A minus W equals 240. Oh, well, what's nice about this, if we do elimination, is we don't have to make any changes at all, is because the wind speeds are going to be canceling out. And so I end up getting, if I add these two equations, I get 2A equals 520. And if I divide both sides by 2, I get an airspeed, the airplane speed, of 260 miles per hour. Can I find the wind speed too? Of course, I can find the wind speed if I go to the first equation here and I plug in the airspeed of 260. The question is plus W equals 280. Then I subtract 260 from both sides and I get a wind speed of just 20 miles per hour. And so the question asks me find the airplane the plane's airspeed and the wind speed. So my wind speed is 20 miles per hour and my airspeed is 260 miles per hour. Now, this is the first time you've done one of these things. So let's go ahead right to another one and let's not panic. So I know that looks pretty advanced. But I think if you see 2 more, and we'll do 2 more, you'll kind of get the hang of it. The key thing is looking at the velocity, the head speed, the headwind is added and on one and subtracted on another. Let's just go to another one though. So let's go to the next page, and let me. I feel like you all probably hate me after that first one, but well, Let's see what. Let's see if this one's any better. Okay. Again, this is going to be, it's a one of these ones with a current of air. It says with a headwind, plane traveled 840 miles northward in 2 hours. With the same wind speed as a tailwind, the return trip southward took 1 hour and 45 minutes. This is one, because we're going north. Okay. We're going north first. And we can go ahead and get an image of this. It goes 840 miles north. And in this case, what's going on is it's got a headwind that's blowing against it. But and then it comes back down south, the same distance for 840 miles per hour. Now, when it's going north, it's got a headwind, so it's being slowed down. So that means that you have the airspeed and the headwind is slowing it down. So it's going to subtract from the airspeed the wind speed. Going the trip back down south, you have it says you have a tailwind with the same wind as a tailwind. You go back south, and that means that the wind is speeding you up. So here we go again. We're going to do the exact same thing. Velocity times time equals distance, and we're going to fill in this chart. And again, we have the trip, and then we have the return. And that's going to be pretty much the case for all these problems. So the velocity for the trip up is going to be A plus W. And the velocity for the trip back is going to be A minus W. Oh, God, I cannot stand it when I keep doing the same thing over and over. But anyway, it is the opposite. Who just noticed that? Thank you. The trip is with the headwind minus, and then the return is going to be, it's going to go with the wind. It's going to speed up. The time, 2 hours for the trip up. And that's going against the wind. It should take longer. And the distance, in this case, is going to be 840 again. How do we translate 1 hour and 45 minutes, though, into a decimal? How much of an hour is 45 minutes? So we could either convert everything to minutes if we wanted, or we could just keep it in hours. So I'm just going to keep it in hours. And 45 minutes is actually 3/4 of an hour, 0.75. So 1 hour and 45 minutes in hours should be 1.75 hours. And again, the distance is 840. Okay, so without getting crazy, let's go ahead and write our equations. So for the trip, 2 hours times A minus W equals 840. And the return trip, 1.75 times A plus W equals 840. Just like you might hope, if I divide both sides here by 2, whoever created this problem made it so that it would come out nice and neat. It's just going to be A minus W equals 420. And as you might suspect, you could also divide both of these sides by 1.75. And who can do this one? Well, it's going to be A plus W equals 480. Okay, I admit I used a calculator on that. So you can do. Again, we get a really simple, nice, gentle elimination setup here. Just going to add both equations. I'm going to get 2 times the airspeed. The wind speed cancels, equals 900 Airspeed equals 450. So if that's the case, let's take this equation here. Let's take the second equation. We're going to get 450 plus W equals 480. And I think if I subtract 450 from both sides, I should get a wind speed of 30 miles per hour. So there it is. So let's go ahead and do that again. We just need to figure out if it's a headwind, it means it's hitting the wind is slowing it down. So on the trip 2, we have a headwind, slows things down. So we get the A minus W, put the time in and the distance. For the return trip, we have the wind working with us, and so call that a tailwind, and that makes us go faster. So we make the trip in a shorter time, 1.75, but the distance is the same. Again, we multiply velocity times time in both cases to get an expression for the distance, and the distance equals 840. Reducing the equations a little bit to simplify them, we get this nice, neat equations all ready for elimination. Let's do, I would love for you, if you think you have any confidence at all in these, you can go ahead and we're going to go to one more. We'll do one more problem, and then you'll have 2 of these to do for homework. So take a moment, pause this for a moment, see if you can understand everything that happened here. Again, it's a combination of velocity times time equals distance, and also this idea of tailwind and, this, being pushed with the current of air or being hindered by the current of air. So we're going to go to the next the third and final problem. I'm sure you're all very happy about that. So here we are on example 8. I'm sure you're all really excited about this by now. Anyway, bear with me all. Stop shaking your head. Anne can paddle her canoe 15 miles downstream in 2 hours. The return trip upstream, guys, that in river language, that means you're going against the current, takes 3 times as long. What is the rate of the current? Well, let's call the current, the speed of the current, we're going to call that, we're going to call the current C. Oh, actually, that doesn't, that's not very good. Let me call the current the water speed. All right, we'll use a W. Speed of river. And then the C will be the speed of the canoe. So, same formula. Velocity times time equals the distance. And so what will we have for the velocity? It says she can paddle her canoe 15 miles downstream. Well, okay, if you can pause this for a moment and just tell me for a moment, think about it. What's going to be the velocity? Downstream means that it's going to be the speed of the canoe. Is it going to be plus or minus W? So again, this is the trip. This is the return. Did you figure it out? Okay, well, there it is. Downstream means with the current, so we're going to say the canoe speed plus the water speed. The time is 2 hours. In the distance, read the problem. What does it say? 15 miles. Okay, now let's move to the return trip. It's going to be the canoe speed, what? Minus the speed of the water. All right, slower. Because it's slower, it takes more time. How much time? It says 3 times as long. Well, if it's 2 hours in one direction, what's 3 times longer than that 2 hours? And the answer is, Kobe, good job. It's 6. And so, and again, the distance doesn't change. And we have two equations now. We have 2 times c plus w equals 15. And we have 6 times c plus w equals 15. Now, this one, these equations don't reduce nice and neat like the other ones did. So what we're going to have to do is we're going to have to distribute and do with it all the old-fashioned ways. So we got this, distribute the 2. So we get 2c plus 2w equals 15. And now we have, and this equation becomes, okay, yeah. This equation becomes 6c plus 6w equals 15. So let me rewrite the equations. I think that what I'm going to do is elimination. You guys can do whatever the heck you want, but I'm going to multiply the top equation by -3. Oop. I messed up here, didn't I? Who saw this? Who saw that I made this error here? Someone's got to tell me. How do I get rid of this thing? Oh, I hate this. This is... Okay, good. That's good. Yeah, the bottom one should have been a minus sign. Right? It says 6 times c minus w. Okay, again, though, I am going to multiply the top by a -3. Or I could just multiply by a 3. What do you got? Okay, raise your hand. What do you want me to do? Actually, I'm just going to multiply it by 3. Positives are so much nicer. So let me rewrite both of these equations. Let me rewrite the top one. I'll distribute the 3, and I'll get 6c plus 6w equals 3 times 15 is 45. And I won't touch the second one. 6c minus 6w equals 15. If I add them, 12c equals 60. C equals 5 miles per hour. That's the speed of the canoe. Can we figure out what the speed of the water is? The rate of the current. So let's go ahead and let's take the simpler formula. And that was 2c plus 2w equals 15. And let's plug in the 5 for the c. So I get 2 times 5 plus 2w equals 15. I'm going to add, this is going to be 10 plus 2w equals 15. Subtract 10 from both sides. 2w equals 5 divided by 2. The water speed is 2.5 miles per hour. Okay, so that is the solution. Again, you might want to take a moment and make sure that you can understand what's going on with those 3 problems. I'm sure the first one was, I apologize for being so long-winded. I probably should have just done it a little quicker, but hopefully by now you can understand how these problems work and that we can now move on to the homework. Your homework is going to be, let me go ahead and move up here, it's page 71, 5 and 6, and page 132, 1, 2, 7, 8. So what I'll do is I will, I think I'll copy those questions down and put them on the next 2 slides. And I'm going to, just so you know, there's also under the assignment, you can see a place that's I'm going to write the slides only. That's what I'll write. It'll be slides only. What I can do is I can save this presentation so that you can just see the slides, and that'll allow you to see the homework questions. Okay, so I'm gonna go to the next page, and I'm gonna take some shots of the work, and you can, like I said, you can go to the My Essay. Instead of clicking on the video, you can just click on the other side where it says downloads, and you'll see the slides. And on page 6 and 7 of the slides, or maybe I'll get it all on 6, you'll see the questions. So here we go. Okay, so these are your problems. You can see them on slide 6 and slide 7. All right, so good luck with that. When you're done with this work, feel free to work together, but when you finish with the work, please feel free to do other things, and it's likely that the substitute's not going to be allowed to let you out early, so go ahead and occupy yourselves, and try not to disturb other people that are working, though, please. Anyway, I'll look forward to seeing you guys on Monday. Have a great weekend, and hopefully get your work done so that you'll be free of math, so that you have a more enjoyable week. I don't know, a little more fun during the weekend. You take care, everyone. See you soon.